In this exercise, we are given an extensive form game with imperfect information and without nature, and we are asked to provide its normal form, reduced normal form, sequence form, and agent form representations. Let us start with the normal form. Player 1 has two information sets, therefore her plans are couples of actions. The first element of the couple is an action from information set 1.1, one among L1, C1, and R1. The second element corresponds to information set 1.2, and it can be either action L2 or action R2. Analogously, player 2 has two information sets. Thus, our plans first specify an action at information set 2.1, either L1 or R1, and then an action at information set 2.2, one among L2, C2, and R2. Finally, player plans are obtained by taking all the possible combination of actions at different information sets. Now, let us fill the payoff matrices. If player 1 plays plan L1, L2, then payoffs are AB whenever player 2 plays L1 at information set 2.1, otherwise if player 2 plays R1, they are EF. We have a similar situation when player 1 plays plan L1, R2. Instead, if player 1 plays any plan involving C1, then player payoffs are IJ, KL, or MN, depending on the action played by player 2. Finally, if player 1 plays any plan involving R1, this leads to payoffs OP. This is the normal form representation. Let us construct the reduced normal form. Note that if player 1 plans to play action C1 at information set 1.1, then player payoffs do not depend on what player 1 plan prescribes to play at information set 1.2. Thus, we can collapse the two plans into a single one, namely C1 star. Here we have an analogous situation where the two plans involving R1 are merged. Finally, this is the reduced normal form representation. Now we build the sequence form. First, we enumerate the sequences. The root node defines the empty sequence for both players. Node 2.1 defines sequence L1 for player 1. Node 2.2 defines sequence C1, while node OP defines sequence R1. The left node in information set 1.2 defines sequence L1 for player 2, and the right node defines sequence R1. Node AB defines sequence L1, L2 for player 1, and we can go on as usual and enumerate all sequences, as in picture. The payoff matrices are built as usual. If player 1 plays sequence L1, L2, and player 2 plays sequence L1, then outcome AB is reached. Instead, CD is reached when player 1 plays L1, R2. We can go on, and these are the final payoff matrices. Now we show the sequence form constraints on the strategy plans. We have the usual constraint that places probability 1 on the empty sequence. Information set 1.1 defines a constraint enforcing that the sum of realization probabilities of sequences L1, C1, and R1 must be equal to the probability of the empty sequence, which is 1. Finally, information set 1.2 forces the probabilities of L1, L2, and L1, R2 to sum up to the probability of L1. These are the final constraints in matrix notation. You can do the same for player 2 constraints. Now we conclude providing the agent form representation of the game. Remember that in the agent form, each information set of the extensive form corresponds to an agent that is a new player. In this case, we have 4 information sets, therefore 4 agents. In the picture, you have a representation of the agent form. Agent 1.1 selects a row in the inner matrices, agent 1.2 a row in the outer matrix, agent 2.1 a column in the outer matrix, and agent 2.2 a column in inner matrices. Moreover, notice that agents corresponding to information sets of the same player share the same utility function, that one of the player. For instance, if agent 1.1 plays L1 and agent 1.2 plays L2 and agent 2.1 plays L1, then agents payoff are AB.